The topic of this lecture will be the double dehydrohalogenation of alkyl dihalides to synthesize alkynes. Alkyl dihalides are alkanes that contain two halide substituents, either on the same carbon or on neighboring carbons. Both of these types of alkyl dihalides will undergo elimination with base and heat to form the alkyne. Although we won't talk about a specific mechanism, both of these alkyl dihalides undergo the loss of HX to form the alkene as an intermediate, then undergo the loss of a second molecule of HX to form the alkyne product. The strong base that is used can either be potassium hydroxide or sodium amide. If there are two possible alkynes with different substitution that can be formed, the potassium hydroxide will favor the formation of an internal alkyne, while the sodium amide will form the terminal alkyne. Now, let's look at some examples. Double dehydrohalogenation of this alkyl dibromide can give two possible alkyne products. If the two hydrogens that are eliminated are the two hydrogens on the terminal carbon, we get the terminal alkyne. If, however, the two hydrogens that are eliminated from the more substituted carbon, we get the internal alkyne. Sodium amide and heat favor the formation of the terminal alkyne, while potassium hydroxide and heat favor the formation of the internal alkyne. The reason that sodium amide favors the formation of the terminal alkyne is that the amide is a strong enough base to deprotonate that terminal alkyne once it's formed. It is this Bronsted-Lowry acid-base reaction that helps push this reaction, the formation of the terminal acetylide ion, to completion. In order to get the terminal alkyne, we must protonate that acetylide ion, typically using water. The sodium amide and heat must be added first, followed by addition of water, in order to get the desired terminal alkyne product. In some cases, certain alkyl dihalides can only eliminate to form one single alkyne. For example, this alkyl dihalide can only form this alkyne product. In this case, it doesn't matter whether we use potassium hydroxide or sodium amide.